All right, now we had just solved this, or we just come up with the equation by using the point-slope formula. Now the question is, can I get the same answers if I'd use the slope-intercept form? Well, with the slope-intercept form, you know that y equals mx plus b, right?
We can't see.
I'm working on it. Y equals mx plus b.
You had it. Perfect.
Y equals mx plus b. So what was your y coordinate in this last problem?
1,
So 1 equals, what was your slope?
-3/4.
-3/4. What was your x?
17.
10. And so b is what you were looking for, right?
Yeah.
Now, what you may want to do is look at this as 10 over 1. Reduce that. How do you reduce this? 4 and 10 reduced with a common factor of 2. You get 5 and 2. Do you all agree? So now you got to deal with fractions. Let the crying begin. So 1 is equal to -15 halves plus b. If you add the 15 halves to both sides, you're going to have to worry about getting a common denominator, which should not be too bad, because if you rewrote 1 to have a denominator of 2, what would its numerator be?
You had the
It'd be 2, right? What's 2 halves plus 15 halves?
30. Where did?
Plus 17 halves.
You get 17 halves for your b, right?
Where did 2 over 2 come from?
That's what 1 equals, when you make that an equivalent fraction with a denominator of 2. This is an exercise in working with fractions, which is not something that we should be slowing down on, because you have that as a prerequisite for this course. So I find that b equals 17 halves. What was my slope? What did we say my slope was from the beginning? It was -3/4, so it means when I put these guys together, y equals -3/4 x plus 17 halves, which is the same thing that I already had.
How'd you get 17?
How do you get 17 halves?
So,
Remember that
Did you-
1
Okay.
is 1 over 1. So you get that common denominator by multiplying top and bottom by 2. And you get 2 over 2.
because you're using 2 as a
Common denominator.
all the way across.
I'm just combining 1 with 15 halves. So it's just an exercise in adding fractions. Getting that common denominator. Fractions are never going to go away. We will have them all the time on every test.
Well, that's fine, I just didn't know how to go with that 2 over 2.
Right, and that's just when you work with fractions, you want to get equivalent expressions for them. Like when I say $1 is 4 quarters, 4 over 4, or 10 dimes, 10 tenths of a dollar, 10 over 10. Just having a way to rewrite it so that we can combine them with things that are alike.